Hey everybody, it's Dr. Wood, and today we're going to be covering Chapter 8, where we talk about converting between different measurement systems. And so, in terms of an introduction, this is basically where we're talking about converting things from one form to another. And this is a very necessary step in the medical field. You're going to have to do this all of the time. While there may not be a 100% world standard, you're going to find that most places you get very used to using whatever conversions that they use most commonly, right? Whether you're using metric, whether you're using imperial units, whatever the case may be, the conversions are necessary. When you're converting from one system to another, typically it's not going to be a complete one-to-one sort of transition there, because you end up dealing with a lot of decimal places, and it gets very hard to remember a lot of conversions and things like that. Usually, the conversions are going to be within 10% of one another. Is generally fine, right? So you'll find that pretty commonly seen in medicine. The first conversion we're going to talk about today is going to be time conversions. And I'm sure most of you are pretty well used to using the standard 12 o'clock English clock here, right, where everything is divvied up into AM and PM. One of the inherent problems with this is that if you're, say, talking between two medical professionals and say, oh, well, when did you give the medication? Oh, I gave it at 3 o'clock. Unless they very explicitly specify, oh, is it 3 a.m. or 3 p.m., because medicine generally is a 24/7 sort of business in a lot of cases. There may be confusion and there could be errors that pop up there. However, if you could say, for instance, oh, I gave it at 1500, then that's very explicit. You know that's going to be 3 o'clock in the afternoon as in terms of a conversion. So anyways, how do you actually work with that, right? This 24-hour sort of international clock, where basically from midnight is generally going to be considered to be, 0000, basically. And then it goes over to 1 o'clock, 2, 3, 4, 5, all the way up until you hit 12. And then at that point, it's going to convert over into 13, 14, 15, 16. The really easy way to do this is if you just go ahead and say someone reports out a time, oh, it happened at 1700, just subtract 12 from that, and you'll figure out what time it is in the sort of standard 12-hour clock there. So if someone says 1900, you just subtract 12 from 19, and you get it's going to be 7 o'clock, essentially, 7 o'clock in the evening, okay? The way to convert from the 12-hour standard clock over to the international 24-hour clock would be just to add 12 to it. So if you say, hey, I'm supposed to give this medication at 8 p.m., 8 plus 12, you're going to get 2000. Now, occasionally midnight will either be 2400 or be, 4 zeros, essentially, 0000. Either one of those would be totally appropriate here. So let's test our understanding here and see if we can make a few conversions here between various times of day into their, from the 12-hour clock over the 24-hour clock. Let's say here at 4:40 a.m. This one's pretty straightforward because it is in the early part of the morning. Within that first 12 hours, you basically just put a 0 in front of it and you're kind of done. So you can say 0440 would be the appropriate 24-hour sort of standard clock time. How about 6:25 p.m.? Well, since this is past 12 noon, you're going to see that this flips over. And so basically, because we have something happening after 12 noon, we're just going to add 12 to this 6 here. So this is going to turn into 1825. Okay. How about 11:02 a.m.? Again, this is before noon, so I don't really have to do anything to this. There's no conversion needed for it. So this would just be 11:02. Same thing here for 2:56 a.m. This would just be 0256. 10:45 p.m. Okay, so again, this is in the second half of the day, so I'm going to go ahead and take 12 and add that to 10. So you should get 22:45. For 8:10 p.m., again, we're going to add 12 to this because it's a p.m., so it's in the second part of the day. So this is going to end up being 2010. 12:30 a.m., right? So this would be in the very early period of the day. This would end up being converting into 0033, right? So 0033 would be the time frame at basically right after midnight, essentially. 10 a.m. no conversion here needed. It's just going to be 1000. 3:33 p.m. add 12 to that, and we're going to get 1533. And then 7:12 a.m. very easy again. No need to add 12. We're just going to get 717 here. So pretty straightforward. It just takes a little bit of time to get used to making these conversions. And after a while working in the medical field, you'll be able to do the conversions back and forth in your head with no problem. Other things, how about measuring temperature, right? In the metric system, temperature is usually going to be used in Celsius. And over here in the US, we're typically used to using things in Fahrenheit. And so you're going to find that there is a little bit more complicated conversion here than just maybe adding or subtracting 12. But in general, you're going to find that 0 degrees Celsius is going to be equal to 32 degrees Fahrenheit. And so this 32 degrees will be important for some of the conversions that we're going to be looking at here. Now, you want to be really clear when you're when you're reporting out on a patient's temperature, because if you goof this up, it could mean very dire things. So as an example, it is not unheard of for a person to have a 100-degree Fahrenheit temperature. But if you reported out that your patient had a 100 degrees Celsius temperature, you might assume that their blood is boiling in their veins. And while some of you may get that mad sometimes your blood's boiling, patients don't normally do this, right? And so just to show you examples of how the Celsius compares to Fahrenheit, 100 degrees Celsius would be around 212 degrees Fahrenheit, so quite warm. Normal body temperature in Fahrenheit is 98.6 degrees. I'm sure most of you have heard that number before. This converts over to 37 degrees Celsius. And if you said, hey, my patient's 37 degrees Fahrenheit, you're going to think a patient's pretty close to freezing, right? So again, this is why keeping your unit straight is very, very important. Room temperature is around 20 degrees Celsius, where it's 68 or so. That's actually pretty chilly around most parts here. I don't know who's paying for the air conditioning to make it 68, but there you go. And then where water freezes, 0 degrees Celsius, whereas it's going to be 32 degrees Fahrenheit. So how do we make these conversions here from Celsius over to Fahrenheit? Basically, you're going to take the Celsius temperature, multiply it by 1.8, and then you add 32 to that. Alternatively, if I want to go from Fahrenheit to Celsius, you basically do the opposite. So I would go ahead and subtract 32 from the degrees Fahrenheit, and then divide that by 1.8. So in that way there you can kind of interconvert between the two. Because you may have patients that come in, for instance, and they took their temperature at home and they reported out to be, it's 101.3 degrees Fahrenheit. And then in your computer system you have to convert it over to Celsius. So it may be something you have to consider doing depending on where you work and what kind of units you're used to using there. Okay. So let's look at how we can convert between measurement systems using ratios and proportions. I'm going to show you a few different ways to make these conversions here, but this is going to be one of the first ones we're going to look at. Basically, we can use this to convert when the dosage is available, but it's not in the same measurement unit as maybe the doctor or the nurse practitioner or PA prescribed. And so with the ratio, you're going to see this is basically an expression comparing two quantities, whereas a proportion is comparing two equivalent fractions or ratios. And I'll show you some examples of what that looks like in just a few moments here. Basically, we have to solve for unknown variables, right? So we've already talked about some pretty basic algebra that we're going to be using here in the past chapters. And we're going to make sure that whenever we're doing things via ratios and proportions, that our numerators are going to be the same units. We're going to be making sure that the denominators should also be the same units, such that if we were to compare, say, for instance, milliliters to drops, say 1 ml is to 15 drops is the same as 2 mLs to 30 drops, right? So these are going to be equal proportions here. Versus if I was looking at, these would be equal ratios here, versus an equal proportion would be 1 ml over 15 drops is equal to 2 mLs over 30 drops. They're essentially saying the same thing, it's just a different way to notate it. So let's look at a few different ways we can solve these conversions using ratios and proportions. Myself personally, I like using the fractions here. It tends to work out a little bit easier in my mind. But for this one, I'm just going to go ahead and multiply the denominators for each side by the numerators on the opposing side. So here we're going to see that 2x equals 4, and then just divide that 2x, or divide both sides by 2, and boom, you have x equals 2 grams. Fairly straightforward. Here, if you remember, we're going to do the extremes have to equal the means, where 2 mLs times 2 mLs times x grams has to equal the same as 1 gram times 4 ml. And again, doing the same thing, just dividing out 2 by both sides, you're going to get the same exact answer there. Again, 2 ways to tackle the same exact problem, you get the same exact answer. Remember when you're setting up both ratios that you want to label all of the terms, including x being your variable, because you want to make sure you get the right measurements. You want to make sure that you are, if you're solving for grams, you want to come up with the number of grams that you're actually looking for there. Again, some pretty common conversions you're going to be using pretty frequently in the medical field. I will say here that some of the common ones that I deal with, at least in the hospital pharmacy, is going to be, actually I'm just going to cross this out. This will be a post that I'll make up on web courses as well that will show this. But basically 5 mLs is 1 teaspoon. Pretty straightforward. 15 mLs to 1 tablespoon. I believe we talked about these units previously. 30 mLs to 1 ounce is very common to use that. So being able to convert between the two there can be very handy, right? This is also equal to 2 tablespoons, which makes sense based off the fact we know 15 mLs is equal to 1 tablespoon. And beyond that, those are probably the most common ones, but certainly being able to convert between, say, an example as a cup is 8 ounces. There's also 240 mLs. That'd probably be another one to use a little less frequently, but still common enough. And so on and so forth until you get all the way up to the gallons there. But the ones I underline are probably the most common ones that I use on a day-to-day basis in hospital pharmacy practice. Now, for my purposes here, I'm going to go ahead and just X out this whole apothecary system. I'm going to make sure I eradicate this from any of your quizzes or assignments, mainly because it's an old system of measurement that we don't really use anymore in hospital pharmacy. Maybe if you go and work in a compounding pharmacy, but not very common. Some conversions I will make note of that I think are quite important. They're going to be things like 30 grams is equal to 1 ounce, which makes sense because we talked about 30 mLs being equal to 1 ounce, and basically 1 ml is equal roughly to 1 gram, so that makes sense there. This is another big one, is that 1 kilogram or 1,000 grams is equal to 2.2 pounds. Now, I've seen some people on their assignments, they're getting a conversion, which I have no idea where they're getting it from, but they're getting some conversions out to like the thousandths place, and you don't need to do that. 1 kilogram to 2.2 pounds is a super common conversion that we use all the time, especially when in pediatrics. So if I have a parent that comes into the ER and they say, oh, my kid weighs 10 pounds, I can easily convert that over to kilograms by using this conversion here. Or if they come in and say, oh, they weigh 44 pounds, I know that right off the bat that equals 20 kilograms, right? So those are common ones that we'd use there. Also, be able to convert between your different sort of metric system units of measurement here, right? So you should know that 0.1 gram is equal to 100 milligrams, right? Because we know that 1 gram is 1,000 milligrams, so it stands to reason that 0.1 grams equals 100 milligrams. Or if I were to give you, say, something like 0.015 grams, you should be able to convert that over to 15 milligrams, right? Again, it's just a matter of moving the decimal place over to the appropriate spot. And we've covered that in previous chapters. Other ways we can do this, if we wanted to convert, say, from household to metric, right? So let's say, for instance, I have a male patient who weighs 175 pounds. How many kilograms would this be? And so the easy conversion here is that 2.2 pounds equal to 1 kilogram. And I can just set up a proportion here that will help me to solve this. So 2.2 pounds to 1 kilogram equals 175 pounds to X kilograms. By actually solving for X, what I end up getting is that 2.2 times X equals 175 times 1. And then just take that 175, divide both sides by 2.2, and I basically get X equals 79.5 kilograms. Okay. Now this is important when you do this conversion because most drug dosing that you find is going to be based off the patient's weight in kilograms. And this is something we'll mention in the next chapter coming up. But again, it's really, really important when doing drug dosing based off of weight that you always get back to kilograms. That's always what you want to be dosing your patient off of. In terms of length, this is something I use a little less commonly just due to the fact that pharmacy isn't really that physical of a discipline. But you may be using this in other disciplines. So if you're in surgery and you want to estimate how large of an incision you made, things like that, this can be really important here. So one conversion I will say we use quite frequently, though, is going to be the conversion from centimeters to 1 inches, and so basically 2.5 centimeters is equal roughly to 1 inch. Now you may find some places that use 2.54 centimeters. That's probably a little more exact, but if you recall, we said as long as we're within 10%, generally we're pretty good. So for my purposes, for assignments, 2.5 centimeters to 1 inch, totally fine here, right? And this is probably the most common one you're going to need to do for just any general health profession purposes. So let's say, for instance, we wanted to make one of these conversions. We have an abdominal cavity that was opened up with a 14-inch incision. It's a pretty big incision, but let's see how many centimeters that would convert into. And so here you can see we have 2.5 centimeters is equal to 1 inch, right? And we just set up that proportion. So 2.5 centimeters to 1 inch equals X centimeters per 14 inches. By solving for X, basically it's just going to be 2.5 centimeters times 14 inches divided by 1 inch. These inches will cancel out, and you basically have left over is 35 centimeters. So that 14-inch incision is equivalent to a 35-centimeter incision. So that's it for this section. If you have any questions, please let me know, and I'll talk to you soon. Thanks a lot.